So hello. So the next speaker is, this is two last talks. They're going to be about the people who are using TensorFlow, and Ieva is representing here a startup community, a private sector basically in industry using TensorFlow for their development. She can tell what works, what doesn't work, and how she's implementing it. So a few words about Ieva. I know her already for more than a year. She's frequently coming to this meetup, so if you come for a next meetup, probably gonna meet her. Also, you can ask more questions. She's CTO of her own company. She doesn't like this name, but this is what she is. And she's a main developer of the entire software package they are basically constructing and building in this company. She started her education on higher education in biophysics at Vilnius University, and while studying, she was already helping an AI company, which is iSense, developing the software for people, blind people or blind-sighted people, partially blind-sighted. And then she worked for 3 years in Human Computation Institute, working on very cool 3D images obtained by two-photon confocal microscopy, and with dynamic movement of the blood in mouse or rats' brains fragments. And also she was working on gamification of the science. And I really recommend you to talk to her, because just recently, like 2 months ago, they incorporated in her company. They get some initial fundings, and you can talk with a person who just went through the path of developing the product and deploying it, proving that it's working, getting some money, and many of you is thinking about private company or starting a startup. So this is the person to talk to.
Okay, so hi everyone, and thank you, Pavel, for presenting me as a better person. And I'm really happy to see so many people, many of you here, because it looks more like a rock concert than a technical meetup. And today's topic is building a reproducible machine learning pipeline, and perhaps that's a good moment to say thank you for Google Cloud team who supported us while exploring Google platform tools. And just to start with, I will present quickly what is Attention Insight, what we do, what kind of data we deal, and why we care about building reproducible machine learning pipelines. So, digital marketing experts estimate that average American sees from 4,000 to 10,000 ads per day. And of course, luckily, they start filtering and do not engage with each advertisement. But as a content creator, is it possible to make Americans' life even worse? Or if more seriously, is it possible to use the data of eye tracking data to make better attention-related decisions? So in Attention Insight, we thought to take eye tracking data to feed a neural network and get a prediction in a few seconds. But is it possible in general to predict where people are looking? Maybe we all are unique and look where we want. So I will make a quick experiment and we'll show next slide for a few seconds. So here's our model prediction, but who of you noticed the message on the top? So I would say that attention could be predicted. So it means that instead of taking expensive experiments that takes a lot of people, human resources, time, and money, we would predict maybe not so accurate, but give prediction in a few seconds and allow to improve usability in that way. So attention could be predicted, just lots of data is needed. And everyone who ever worked with biological or neurological data would resonate with my pain. What does it mean to clean the noisy data or preprocess that in different way, so you would see different phenomena or get a little bit slightly different data and put in the same pipeline and train it again and again, so it would produce normal results. So here's today's topic steps in. And imagine that you have machine learning code, like it would be our brain. Actually, a small brain. And what does brain needs to survive? It needs math as a data collection. It needs feature extractor as stomach. Even what kind of data you mix, it has to extract features to fit into standard. Data verification as gut, process management as liver, lungs as machine resource management, monitoring as immune system, and serving infrastructure as a muscles that could bring our brain to the goal. So it is super challenging, actually. Even machine learning code is important. It's super challenging to group all these parts together. And we had a question, what could be, we had our machine learning code written in TensorFlow, and we wanted to make it more reproducible or slightly easier to repeat all the pipeline again and again. And what tool could be portable, scalable, and glue, and potentially have a good community? So there are many answers for that. Even today you heard the different aspects of the same pipelines problem, but I will speak about Kubernetes and Kubeflow, because it releases some pain when you develop a code in your own computer or development environment, and then you have to think about that one day if you will be successful, you have to scale. Or for example, you get resources in university and you have to move to many GPUs or whatever. So how to make that good environment at the start? So Kubernetes is an open source platform for managing Dockerized applications. So it takes care about infrastructure. It means it allocates resources like how many computers, how many nodes, okay, I will call it computers, do you need, and how to organize so you have enough memory, enough resources, and so on. And approximately 1 year ago, Google released Kubeflow that you can imagine as a glue for Kubernetes and your machine learning code. And its main goal is to make it easy for everyone to develop, deploy, and manage portable distributed machine learning on Kubernetes. So sounds good. So how you can start? So Kubeflow team made a good job and made really easy start on Google Cloud Platform. Just select a project name, a development name. You can skip more difficult part and you are good to go in 10-15 minutes. But to mention that, Kubeflow is not dependent to Google Cloud Platform. You can run it on any major cloud provider or university code where Kubernetes are installed. Also, it's not dependent on TensorFlow, so if you are developing code on Torch, until it is Dockerized, you can use it for the same pipeline. So let's dig a little bit deeper. So it's a simple project structure where you have data ingestion, train, evaluate, model, and deploy. It's like separate folders, and you can notice that they have a Docker file in it. So you can make Docker out of that application. And I just remember that in previous slide I mentioned Docker a few times, but I haven't said that it's a way to package your code with all dependencies, and it's package code in your, okay. Sorry. So you can make a Docker file of each your pipeline step and make one file there where you can give input parameters. So that file would know how to deal with input and output parameters. The same pipeline in Kubeflow interface, UI, would look like this. Yes, Kubeflow has UI. And you can see like 3 parts, and you can put all your input parameters to the pipeline, output parameters, and try to run. Yes, so pipeline could be defined in Python file, but also for those who love notebooks, it could be defined in Notebook as well. And Kubeflow goes together with Jupyter Hub, and it could be easier to share your notebooks in Jupyter Hub because you can develop your notebook locally and import it on Jupyter Hub when you finish and want to share with your team members. So your pipeline is ready, so you can start running it. And what I like here, you can make several runs, can make a cron job to repeat those runs, and you can see in runs your metrics values, like in this time accuracy score and ROC-AUC score. And if you mark these 3 lines, you can compare input parameters that you chose for the pipeline itself and make maybe a quick assumptions which run is the best. In the same time, while container is running, Kubeflow saves the logs for each container. So it's quite convenient to see everything in one place. And actually, there are a lot of features how you can store logs or any metadata or TensorBoard more or less in the same Kubeflow UI. Reusable machine learning pipelines. So it actually comes down to the Docker. So if you know which of your versions worked the best, you can just take that Docker image as an input parameter into your pipeline and use it as well. For example, if you upgrade TensorFlow to TensorFlow 2, and after half a year you want to check what was half a year ago, you can do with less pain that. So to conclude, next time when I will get more eye tracking data, I will just choose my pipeline name, output directory, project name, fixations, it's like our specific parameters, and then choose the best working images and run the pipelines. So here are a few references that you may like. So it's a quick start how you can deploy Kubeflow, Kubeflow GitHub, very nice article, blog post on organizing machine learning projects and project management guidelines, and Kubeflow examples. So thank you for your attention, and I hope that next time when you will have your all full pipelines, you will avoid these kind of situations. Okay, thank you.
Did you try Airflow and say how the two compare?
Yes and no. My colleague tried Airflow, and he said that Kubeflow main advantage is that it focuses on machine learning, where Airflow, as far as I know, it's like Airbnb, so they may be with big data and so on. So for now, they are comparable, but I expect and I hope that Kubeflow will go far away to work better with TensorFlow Extended and tools like this. So that's why we chose that.
There's a question. Can you use Kubeflow not for machine learning applications, but for simple data analysis or image processing or something like this?
Yes, if your application is Dockerized, you can run on this pipeline. Yep.
One last question.
So maybe I have just one question. So how much in total it took you to develop this software?
I don't know. It's just, it was for a long time as my free time activity. So when you have your free time activity, you don't count.
One final question. So in terms of allocating resources, do you think it's better to use TensorFlow distributed to do it or Kuberflow to do it? Did you compare?
I didn't compare, but maybe we can discuss after.
So thank you very much.